Here we go. We are finding the derivative of arctangent of negative 5x. So when you see arctangent, okay, it's been a minute, but that's one of those ones you're going to review the day before the AP exam. What is the derivative of arctangent? 1 over. What else needs to be on bottom? 1 plus the baby squared. That is the derivative of arctangent. Okay, there was a 5x in there. So what's going to go inside those parentheses? Negative 5x. I also need to multiply by the derivative of whatever was inside the parentheses. So what else do I need to multiply by? Negative 5. That right there is the derivative of arctangent. Okay, we could throw that negative 5 in front, or we could really simplify this thing and make it negative 5 over 1 plus 25x squared. That's what we have to deal with. And today what we're doing is the antiderivative of that. We've got to go from this back to that, and that's kind of tough. Okay, but we're going to figure out how to do that by the end of the day. Arcsine of x over 4. All right, remember arcsine and arctangent are similar. The derivative of arcsine is 1 over something. What's the difference between arctangent and arcsine? Square root 1 minus. Those are the two differences. It's square rooted and it's minus. Inside the parentheses, we could rewrite our baby. So 1/4 x. What else would I need to multiply by? Or that's squared, sorry. What else do I need to multiply by? 1/4. That is the setup. Again, we could write this out. It would be 1 over 4 square root of 1 minus 16 x squared. And we've got to recognize that the antiderivative of that is that. It's tough. You're going to have to use your brain a little bit to try to see that that is that. But that's what we're going to do today. Questions on those two? Last thing we got to do is long division. Okay? Long division with polynomials. It's been a while since you did it. You probably did it one day in pre-calc, one day in algebra 2, and you kind of forgotten since then. Okay? Think back to like 4th grade. Okay? If I took 33 and I did long division with 4, we ask ourselves, how many times does 4 go into 33? It's 8. We would write the 8 up above, and then you would multiply down. 8 times 4 is 32. Then you would subtract. I get 1. That's a decimal, right? Or we could write it as a fraction. What would the fraction be? 1/4, right? It's the whatever's left over 4. 8 and 1/4 is what that is divided out into. Does that kind of make sense what we're doing there? That's the same skill we're doing right here. I'm taking this divided by that. To do this, a quick reminder of what this looks like. We start off with this guy right here. We ask ourselves the question, x times what gets me this first part, which is 2x cubed? X times what gets me 2x cubed? 2x squared. So imagine these are like columns. Okay, in the x squared column, I'm going to write 2x squared. Whatever I write on top, I'm going to multiply back down. So 2x squared times 8 is, 2x squared times x is 2x cubed. And I'm going to take 2x squared times negative 8, which would get me negative 16x squared. I'm going to put these two things together. What did we have to do over here after I multiplied 8 times 4 to get 32? We have to subtract. Okay, so for this polynomial, that means I need to change my signs, because if it was minus, it's going to go positive. I'm subtracting both things. The 2x cubes are going to cancel. Negative 19x squared plus 16x squared is negative 3x squared. We bring down the next thing in the mix here. And then we just do it again. We ask ourselves the question, x times what gets me negative 3x squared? Negative 3x. I write it up above. Then I do it. Negative 3x times x is negative 3x squared. And negative 3x times negative 8 is a positive 24x. I'm putting them together. What do I need to do? Change the signs. I'm subtracting. 3x squareds cancel. This gets me 5x. I bring down the next thing in the mix. And I do it one last time. I ask myself the question, x times what is going to get me 5x? 5. So I write a 5 up above, and then I multiply down. 5 times x is 5x. 5 times negative 8 is negative 40. Change my signs. I get 0. So understand what we just did. We took this really ugly. If I wanted to integrate this thing, this would have been 2x cubed minus 19x squared plus 29x minus 40, all divided by x minus 8. I can't integrate that. That's really hard. But by doing long division, by dividing that out, it's getting this answer right here would be the same answer as just integrating 2x squared minus 3x plus 5. Because that's what I get when I divide them out. That's what this means. It means division. You can take that integral really easy. That integral, we just add 1 to my exponent and divide by my new exponent. Add 1 to my exponent, divide by my new exponent. Add 1 to my exponent plus c. That's the antiderivative of that. That is the antiderivative of this as well, but obviously by simplifying it down first, it made the problem extremely more manageable. Kind of makes sense what's going on there. It's weird. That's where we're headed today. All right. Today, the lesson is called tough integrals. Okay? These are other integrals that look really complicated, that we can't use our basic skills. We can't use substitution. We have to do something else. Okay? My guess is that this is going to be one question on the AP exam. They'll throw one multiple choice question in. A couple years ago, they made it a free response part, and you really couldn't get anything else in the question right if you couldn't do the antiderivative. So that was pretty tough. Okay? So that's why we're going to put a little bit of focus on it, make sure we can do it. Okay? If we have a big bottom fraction, meaning this, like if I have x plus 2 over x squared plus 3, if that's my problem, okay, or if that's my problem, I can do u substitution. Okay, what would you pick to be your u? The bottom, because what's the derivative of x squared plus 3? 2x. It would cancel with the other one. Yay for us, we can move on. So if we just have rational integrals, okay, that's what these are. Rationals mean they're fractions. If you've got fractions, and the bottom denominator has a 1 degree higher exponent than the top, use u substitution, you're good. But that doesn't always work. Okay? Let's look at this guy right here. 3 over the square root of 1 minus x squared. Is the bottom 1 degree less than the top? No. Okay? It's not. It's not 1 degree top. Because what would you pick for your what would you pick for your u here? 1 minus x squared. What would the derivative of 1 minus x squared be? 2x, and nothing's going to cancel with that x, so you're going to get stuck with an x in the problem. We can't do u substitution. So if we can't do u substitution, we got to come up with something else. So looking at this problem, is there any constant in this problem? A 3. So I'm going to take that 3 and factor it out in front. So I pulled that 3 out. Now I'm left with this. 3 times the square root. 3 times the integral of 1 over the square root of 1 minus x squared dx. Gosh, I got to do something with this. Do we know anything that when I take the derivative of it gets me that? That is arc sine. That's what we just did in Bowen. The antiderivative of this is 3. This guy right here would just be arc sine x. That's it. 3 arc sine x. We throw a plus c at the end because I didn't have bounds. That is my antiderivative. That one's tough because you got to recognize it. It's got to be a recognition. We start off thinking it's not u sub. And so my next thought after u sub is it an arc sine or an arc tangent? Okay, let's try another one. 7 over 1 plus x squared. Can I do u sub? No, because you would pick the u would be the bottom, but the derivative of that is x, and it wouldn't go away. So the next thing I'm going to do is factor out any constants. And then I'm looking at what's left over. It's not a u sub. Can I do arc sine or arc tangent? Yes. What would it be? Arc tangent, because I got 1 over 1 plus x squared. That is arc tangent x plus c. Done. It takes some recognition. It involves your brain working in a different fashion, but if you can set it up, you'll do well. Good on that one. Next one. Can I do U sub? Can't do U sub because there's not an x to the first power. Okay, that wouldn't allow us to do that. So instead, we pull out a constant. We get to there. It's not a U sub, and I can't do long division, the thing we're about to learn here in a little bit. We can't do one of those. So it's either arcsine or arctangent for us right now. Which one do you think it is? Arcsine or arctangent? Arctangent, because there's no square root. Okay, so it's an arctangent problem. Well, that doesn't help us here, because if it's arctangent, normally it's in this fashion right here. 1 plus something squared. Everybody agree with me on that? 1 plus something squared. So I'm going to try and set this thing up so it looks like that. So it looks like 1 plus something squared. So what I'm going to do is I'm going to take a 1 out of this guy. So I'm just going to take one of those ones there, and that would leave me with x squared plus 2x plus 1. All right, so this is the same thing as that. I just took a 1 out of that 2 and wrote it out in front. So what that means is I need to rewrite that guy right there as something squared. So again, I've got 1/2 integral 1 over 1 plus. Can I rewrite this x squared plus 2x plus 1 as something squared? It is, think about it. It's a trinomial. We factor trinomials. How would that factor into? It would factor into x plus 1 and x plus 1. Because x plus 1 times x plus 1. Oh yeah, that gets me x squared. If I add 1 and 1, that gets me 2x. If I multiply 1 and 1, that gets me 1. So if I've got two of those, x plus 1 times x plus 1, that is x plus 1 squared. X plus 1 squared. Now is it a arctangent problem? It's in that form we want. It's 1 over 1 plus something squared. So my answer to this question is 1/2 arctangent something plus c. What's going to be my something here? X plus 1. And that should make sense because the derivative of x plus 1 would just be 1. The good news is most of the time if you solve a problem like this, it would be multiple choice. And by using multiple choice, that would help me to start getting my brain going in the right fashion. But again, 2 years ago on the AP exam, this problem right here was in the free response. And if you couldn't get the setup, you were in trouble because you weren't going to get any other points in that problem if you didn't know how to find the antiderivative. Questions here? Try this next one. Same idea. See if you can figure it out. Go. We look at this problem. Dylan, do I have any constants? 5. So he takes that 5 out in front. So it's 1 over x squared minus 10x plus 26. So he takes out a constant. The next thing we look at is, can I do u sub? Not u sub, because the derivative of this would be have an x in it, and it wouldn't cancel with anything. It's not, is it arcsine? No square root, so I'm not thinking arcsine. So then my next thought is arctangent. Okay, is this an arctangent problem? If it is arctangent, I'm going to be able to rewrite it as 1 plus something squared. Okay, and that something is going to come from x squared minus 10x plus 25, because I'm just taking a 1 there and writing it out in front. Everybody with me to there? Then we're going to try and rewrite the rest. So we've got a 5. We've got 1 over 1 plus something squared. Slade, what did you factor this thing into? X squared minus 10x plus 25. X minus 5. Because if I had an x minus 5 times x minus 5, it'd get me that. And so his answer is going to be 5. This is arctangent plus c. All he's got to do is write in what it is, x minus 5. Questions there? All right, let's go to this next section. Okay, I wrote out the long division. I wish I wouldn't have, because if I wouldn't have, you would be better at this. Okay, so I whited mine out. I'm going to do it for you. You can do it with me. Okay, we look at this next one. Sometimes u sub doesn't work, and it's not an arcsine or an arctangent. If that is true, then we're going to use long division. Okay, we use long division when the other techniques don't work. Okay, if you were in Calc BC, you'd learn other techniques. We only got 3. Okay, Is it U sub? Great. If it's not U sub, then it's arcsine arctangent. If it's not that, it's long division. Okay, we are going to use long division. The degree of the denominator is equal to or less than the numerator, and the other stuff didn't work. Okay, so the bottom is the same or less than the top. We look at this. If we were to pick U sub, what would you make your U? The top. Would the derivative of that cancel with x minus 2? No, it's not a U sub question. Okay, so then the next thing I need to do, it's definitely not arcsine arctangent. It looks nothing like that. The next thing I'm going to do is long division. Okay, so here's how we set up a long division problem. X minus 2 goes on the outside. 4x squared minus 3x plus 6 goes on the inside. It's just like bell work here. I'm going to ask myself, x times what gets me 4x squared? 4x. So I write it on top, and then I'm going to multiply it down. 4x times x is 4x squared. 4x times negative 2 is a negative 8x. I'm putting them together. If I'm putting them together, what do I have to do? Change the signs. I got to subtract them. These are going to cancel. This gets me 5x. And then I bring down the next thing. I get plus 6. Then I do it again. I ask myself the question, x times what is going to get me 5x? 5. So I put a 5 up on top. I multiply down. 5 times x is 5x. And 5 times negative 2 is negative 10. I put them together. So I change my signs. X's cancel. I get 16. X times what gets me 16? Nothing. So this is the remainder. Think about in bell work what we did with the remainder. Okay, if we had like 33 divided by 4, we put an 8. We say it's 32. We subtract. That 1 right there means 8 plus 1/4, where we take whatever the remainder is and we divide it by whatever we were dividing by. 1/4. That's the same thing here. So this right here, by doing long division, we can simplify it. This is the same as 4x plus 5. But then I also had a remainder. My remainder is plus 16 over x minus 2, because that's what I divided by. Questions on to that point? Once we've done that, then we are going to just do the antiderivative. Hopefully at this point it should be really easy. Okay, so for example, I'm finding the antiderivative of 4x. I add 1 to my exponent. I divide by my new exponent. It's a 2. What is the antiderivative of 5 going to get me? 5x. Cool, did that one. Then I get to my last part here. 16 over x minus 2. Technically, this is a mental U sub problem. Okay, do I have any constants here? So I'm going to just pull that 16 out. And then I need to take the antiderivative of 1 over x minus 2. That right there, since it's x to the first power on bottom and just a 1 on top, the antiderivative of that is natural, not a plus sign, just natural log. 1 over u. This would be my u. That is natural log. Inside the parentheses, I'd rewrite it, x minus 2. Since it's just x minus 2 and nothing else fancy, I would divide by the derivative. It's just 1. So plus c at the end, that's my answer. Would we do it with bounds? We would not do this with bounds. Yeah, no, we will not do this with bounds. Questions on what I did on that one? It's a little strange, but the long division made the problem way easier. Once we did the long division, once we got it to this step, it was really easy. We just had to get to that step first. Okay, let's look at the next one. We look at this problem. Can I do U substitution? No. Does it look like an arcsine or an arctangent? Then it's long division. Okay, it doesn't look like those, so we got a long division. So on the outside, I'm writing x plus 3. Underneath the division bar, now watch this, 2x cubed plus 4x squared. There's not an x term, so I like to keep everything somewhat organized. So you can write plus 0x, so you can just leave a space, and then minus 5. We've done 2 of them already. See if you can do long division with your buddy. Go. We start off here. I'm going to go fairly quick. X times what gets me 2x cubed? It is 2x squared. I write it above. I multiply it down. So 2x cubed, 2x squared times 3 is going to get me 6x squared. I'm putting them together. So since I'm putting them together, I'm changing the signs. X cubes cancel. Minus 2x squared. Bring down the next thing. So 0x doesn't really do a whole lot for me, but that's okay. Then I do it again. X times what gets me negative 2x squared? That would be negative 2x. I multiply down. Negative 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x. I am putting them together, so I change the signs. Positive. This is going to get me 6x. I bring down the next thing. Negative 5. I do it one last time. X times what gets me 6x? It's 6. I multiply 6x. 6 times 3 is 18. I put them together. I change the signs. Those guys cancel. This guy gets me negative 23. Questions on the long division part. Once you've done the long division, then the problem shouldn't be too bad. Now my problem is just this. 2x squared minus 2x plus 6 minus 23 over x plus 3. That's what's left over. That's dx. And I'm going to go ahead and do the antiderivative. The antiderivative of 2x squared, 2/3 x cubed. We add 1 to my exponent, divide by my new exponent. Minus 2x, I add 1 to my exponent, divide by my new exponent. 6x, I add 1 to my exponent, it's just 6x. Then this guy, okay? If you did it right, you just have an x to the first power on bottom, so that's a natural log one, okay? Minus the 23 comes out in front. Natural log, absolute value, x plus 3 plus c. That is my antiderivative. It takes some work to get there, but that's what we're trying to do. It does not get any harder than what we just did. Questions here? Flip it over to the back side. Let's look at it again. Looking at letter A. Okay? This is a collection of everything. So now we're doing them all. On letter A, is it a U sub problem? No, because if you picked the U, it would be this. The derivative of that would have an X in it and nothing would cancel. So not a U sub. Does it look like arcsine or arctangent? Do it. Here we go. Jesse, what'd you factor out? 3/4 comes out in front. Then he's left with this. That one right there, you guys told me it looked like arcsine because it is. It's 1 over, 1 minus, the baby squared, all square rooted. So this is 3/4 arc sine x plus c. Done. That's just arcsine. Letter, yes, sir.
Do you have to show that step in the middle?
It would be multiple choice, so no.
Oh, okay.
Letter B. Is it a U sub problem? Yes, good. It is U sub. Is there any constants? What could I pull out in front? Do that. If you pull out that 1/4, it becomes even easier. I don't think it's hard before, but if I pull out that 1/4, boom, now it should be right away. It's 1/4. What is the antiderivative of 1 over x plus 3? Natural log. You've got x to the first power on bottom and nothing else on top. It's natural log of absolute value x plus 3 plus c. Let's look at C. Okay. I tried to make it more challenging. I don't know if this was the right day to make it more challenging. We are finding the derivative of an integral. We weren't great at this in our last one. Derivative of an integral. Remember what this looks like. This isn't hard. We did this last chapter. You take it. You plug it in. Guys. We take the square root of x. I plug it in. That's how you take the derivative of an integral. Okay, so right here it's 1 over 1 plus that thing squared is just square root of x. What else do I need to do if I'm taking the derivative of an integral? multiply by the derivative of whatever I plugged in. So the derivative of that is 1/2 x to the negative 1/2. Done. Now, obviously, you could simplify that. That would just be 1 over 1 plus x. And that would be 2 square root of x. But it's the same thing. It's just derivative of integral. We did it last chapter. Don't think it otherwise. Okay? Questions there? What? They have them. It's on this test, so I would make sure you know how to do it. Letter D. Is it a U sub problem on D? No, you can tell it's not U sub because it's a fraction and the bottom is not 1 degree bigger than the top. Okay, so it is not a U sub problem. Is it an arc sine arc tangent problem? No, it's not. So what approach are you going to have to use here? This is a long division problem. Okay, I'm not going to do the whole thing right now. If you want to do it here in a second, feel free. Okay, but what this would look like setup-wise, x plus 1 would go on the outside, x cubed. I would write in that 0x squared. I had people trying it earlier without writing that in, and they struggle a little bit. Plus x plus 0. I'm even going to put a 0 for the constant. You can try that in a second. Let's keep working, but we would do long division. Let's look at E. On letter E, is it a U sub problem? Not a U sub problem. Does it look like a arc tangent problem? You can make it become an arc tangent problem. And the way I'm looking at that, I see the x squared only on bottom. Okay, it's a 1 on it's x squared on bottom. Oh yeah, arc tangents have x squared on bottom. So that's going to be the one where we do something like this, 1 plus something there. Try and do those two. Try and D and E with your neighbor here as we finish up class. See what you can do. There we go. Long division. When I did long division, you can kind of see what I did there, but I got x squared minus x plus 2, and I got a remainder down here of negative 2. So if I'm rewriting this integral, I get x squared minus x plus 2 with this remainder of negative 2 all over x plus 1. All right, if you're struggling with that, I'll put my pre-calc lesson teaching long division again. I'll post that on Schwann Academy if you're still struggling. There's going to be one of these on your test. That's it. Okay, it's not going to be a billion. Okay, and if you're not great at it, do your best guess and go from there. I'm taking the antiderivative, so now it's 3 1/3. Add 1, so it's 2 1/2 plus 2x. The antiderivative of that is minus 2. What is the antiderivative going to be? Natural log x plus 1 plus c. It's a big, ugly answer, but it's an answer. Okay, I've seen it on the AP exam probably every other year. They put a long division on it. Let's look at letter E. I took the 2. I factored it out. This guy right here, I'm going to try to put it in this form. So it's 1 plus x squared plus 8x plus 16. So I need to factor this guy so that it looks like this. What would this factor into as a perfect square? X plus 4. So if it goes x plus 4, my answer is going to be 2 arc tangent. X plus 4 plus c. Questions? As important